Question 3. This question is about white solid MHCO3 that dissolved in water and reacts with hydrochloric acid to give us salt. Got this information here, and then it says calculate the mean titer and use to determine the amount of moles of HCl that reacted with this much MHCO3 solution. So to find the mean titer, well, titers need to be within 0.1 centimeters cubed within each other. So if you look at the titers table, obviously we don't really care about the rough, because that's clearly more than 0.1 centimeters cubed. .50 centimeters cubed is also more than 0.1 centimeters cubed away. So we find out the mean titer within 0.1 centimeters cubed of sugar, so it can only be 9.75, 9.65. 9.5 is 0.25 centimeters cubed away from 9.75 and 0.15 centimeters cubed away from 9.65. So we can't use this as well as 10. So add these two together. How many are there? Well, we're using 1, 2 values. In this case, it's not going to be divided by 4, divided by 3. It's going to be divided by 2 because we're not using the first titer or the rough titer. So we divide by 2, we get this. And then it wants to determine the moles of HCl that reacted with 25 centimeters cubed MHCO3 solution. Moles is equal to concentration and volume. And we know that 25 centimeters cubed sample titrated with 0.102 moles per d cube of hydrochloric acid. And we're trying to find the moles of hydrochloric acid. So it's going to be the concentration 0.102 times by 9.70 divided by 1000. And then we get 9.89 times by 10 to the power minus 4 as moles. Then 3.2, calculate the moles of MHCO3. Well, we know MHCO3 is a 1-to-1 molar ratio from the equation. So the moles of MHCO3 is going to be 9.89 times by 10 to the power minus 4, right? However, it wants it in 250 centimeters cubed solution. This was in 25 centimeters cubed solution. So the moles is still 1-to-1, but in order to get the moles of MHCl3, we just do the moles of HCl, because that was in 25 centimeters cubed solution. Just going to times it by 10. Because how do you get from 25 to 250? We just times by 10. So that will give me 9.89 times by 10 to the power minus 3 moles. And then it wants to calculate experimental value for MR and give you answers appropriate number of significant figures. We know moles is mass over MR. Moles is mass over MR. MR is mass over moles. So mass of MHCO3, which is this, in milligrams, we want it in grams, so we divide by 1000, 1.464. 1.464 divided by MR's mass divided by moles, which is 9.89. We just worked out by timing by 10. And we should get 101.464. Yeah, it looks like a 1. Yep, so I need to change on the calculator. So we get 148, and that is the MR. 148 MR to 3 significant figures. 3.3. The student identify use of the burette as the largest source of uncertainty in the experiment. Using the same apparatus suggests how the procedure could be improved to reduce the percentage of uncertainty in using the burette. Use a larger mass of solid. Use a larger mass of solid. So a larger titer / reading will be needed. Use a larger mass of solid, so a larger titer / reading will be needed. And then 3.4 to mark the end of question 3. Another student is required to make up 250 centimeters cubed of aqueous solution that contains a known mass of MHCO3. The student is provided with a sample bottle containing the MHCO3. Describe the method, including operating practical details that students should use to prepare the solution, the standard solution. Now this could come up in an A-level paper. Not surprised if it has came up before, or will come up maybe in 2025, my paper, because it's just a practical question. Yes, there's a bit of key details here that you might need to include, but apart from that, it's just, how well do you know your practicals? And unfortunately, if you don't, and the thing about this question is it has a mark scheme, obviously, so instead of learning from the textbook, you can just learn from the mark scheme for this specific practical, because obviously you need to know the practical off by heart. But instead of learning from a textbook, which could include, not relevant details, you can just memorize from the mark scheme, which is pretty smart. Well, obviously, it's not going to include every single detail, but it's going to include the details they definitely want you to, the key details. So, stage 1, transfer known mass of solid. So we want to weigh the sample bottle containing the solid on a what? On a balance. Transfer to beaker and re-weigh sample bottle. Record the difference in mass. Stage 2, dissolving in water. When you want to add deionized water, distilled water, and we want to stir with a glass rod until all of the solid has dissolved. And then I'll just carry the rest on stage. Actually, no, I'll just leave it here. Stage 3, transfer, washing, and agitation. So we want to transfer to what kind of flask? To a volumetric flask, or / graduated flask with washings. And we want to, now here's where the key details come from the question. We want to make up 250 centimeters cubed with washings and make up to 250 centimeters cubed. And then the final step, don't forget this, inverts or / shakes. So invert / shake the solution. And that is the end of question 3.